let's move on to the next type of variation, which is inverse variation. When y varies inversely as x, instead of when x is increasing, having y increase, now it's going to decrease. When x increases, the value of y is going to decrease. So what that is that if I have y equals k divided by 2, I get a number. But if I have y equals k divided by 4, I get a smaller number. The higher x goes, the lower y will go. And the same is true. Now if I decrease the value of x, then the value of y would increase. So a great example of this, if you're taking any chemistry courses, especially if you go into Chem 60, is pressure and volume. Actually, this is great for biology and breathing as well. But if you look at these examples, pressure is the number of times or the number of these little red balls that are going to hit the side of your container. So you can see here, they're not going to hit the side of the container as much as they do here. This has an increased volume. This has a decreased volume. So looking at the pressure, when you have an increased volume, you have a decreased pressure. When you have a decreased volume, you have an increased pressure. So that means that pressure increases when volume decreases. So you could say that pressure varies inversely with volume, or you could say volume varies inversely with pressure. It's less likely that you're going to look at a scenario like that. This is the one you more likely look at, but that's kind of what it means from a visual standpoint. But what are the questions going to look like? So here we go. The current in a simple electrical circuit, so current is the key thing there, varies inversely with the resistance. So how are we going to translate into a statement? Current, so let's let C represent current and R represent resistance. If it tells you that current varies, this time inversely, instead of putting the resistance on top, you put the resistance on the bottom. But this is still step 1, writing your variation equation. Step 2 is always to solve for K. It tells you when the current is 80, when the resistance is 10. So I get a current of 80 when the resistance is 10. To solve for K, I'm going to multiply both sides by 10, and I end up with K equal to 800. Third thing, you rewrite your variation equation with that variable K. So I end up with C equals 800 over R. And then the fourth thing is to solve for an unknown. Find the current when the resistance is 16. Current equals 800 divided by 16. 800 divided by 16 is 50. And so current, if you know, would be measured in amps, because you should always put units when you can, but they always come from the question. Okay, next one. The next one is y varies inversely as an nth power. Same as y varies directly as an nth power. The only difference is you're going to put an exponent on your variable. So let's look at an example. P varies inversely as the cube of Q. First thing I'm going to do is write my variation equation. P varies. As soon as I see the word inversely, I'm going on the bottom. It's varying inversely with the cube of Q. Step number 2, you're going to solve for K. When P is 100, when Q is 3. So I get 100 when Q is 3 cubed. So then I can simplify. 100 equals K over 27. To get K by itself, I'm going to multiply both sides by 27, and I end up with K equals 2,700. Step 3, you're going to substitute in that value of K. P equals 2,700 divided by Q cubed. Step 4, solve for your unknown. Find P given that Q is 5. So now what am I going to get for P when Q is 5? Well, 2,700 divided by 5 cubed is 21.6. All right, I'm going to pause the video there. I'm going to get you to go practice. So practice setting up some equations, direct variation and inverse variation. And then the next video, we're going to go on to the next type of variation.